Assalamualaikum and hi, my name is Siti Nur Akila Shakira binti Muhammad Azizan, metric number AD190164. I am from Group F from Section 8. So today I want to tell you guys the introduction of belt friction. A belt is a loop of flexible material used to link two or more rotating shafts. It is considered as a source of motion to transmit power efficiently or to track relative movement. Belt friction is basically a term to describe the frictional forces between a belt and a surface. So in this experiment, the surface was the pulley surface. The belt is wrapped around the pulley and there is a potential for friction between the belt and the belt it is in contact with. So the researchers are trying to find the coefficient of friction between the belt and the pulley for flat and the V-shaped belt. So in this experiment, they will provide us with the tension in the belt and the angle of contact between belt and pulley, which is needed to calculate the coefficient of friction. Next, the objective of this experiment is to investigate the relationship and determine the coefficient of friction between belt and pulley for flat and V-shaped belts. Then, I want to tell you guys about the theory. So basically, friction forces will increase when the number of reps about a pulley increase. As we increase the angle, the friction force on the contact surface also increases, and more weight is needed to cause the weight hanger to fall in constant velocity. Theoretically, the tension acting on the belt can be calculated using belt friction equation. So refer to figure 1, we considered a belt that moves on the pulley with a small angle of the lap, and consider that T is the tension at point A and T plus dt is the tension at point B, and R is the small surface for the pulley rim and the touching belt. Next, refer to figure 2. Figure 2 shows the triangle force where R can be measured, and the change in angle is so small, which is we call it as d theta. The change of the belt tension is dt. Therefore, R is equal to T d theta, and we can call it as equation 1. Then, we know that the coefficient of friction, which is mu, is equal to friction force or action of touching surface. Therefore, dt is equal to mu R, which is equation 2. Then, we can replace equation 1 into equation 2, and the equation will be dt is equal to mu T d theta dt, or T is equal to mu d theta. Then the equation 3 will be log exponent T1 over T2 is equal to mu theta. And from the equation 3, exponent mu theta antilog of log 10 exponent times mu theta is equal to antilog of 0.4342 mu theta, where E is exponent value of 2.718. Mu is a coefficient of friction between belt and pulley, and theta is the angle of the lap, and we can use it in radian. And T1 and T2 is belt type, where T1 is greater than T2. So T1 is equal to M1G, T2 is equal to M1 minus M2 times G, and driving force is equal to T1 minus T2 times R, which is the last equation is basically driving force is equal to Mg. Thank you.
Hello, my name is Nazar Fahmi Abdul Rahim. My matrix ID is AD1014. I'm from Group F, Section 8. So, I want to talk about the result of the experiment. Okay, there are two type of tests, which is test 1 and test 2. For the test 1, it's about angle of lap for flat belt divided into 4 different degree, which is 90 degree, 120 degree, 150 degree, and 180 degree. So there are M1 and M2. The unit is in gram. There are 5 number of repeated of each degree. So the mass 1 and mass 2 give based on the observation. So for the value of T1 and T2, they are from the formula, which is T1 equal to M1 times gravitational force, and for T2 equal to M2 minus M1 times 2 gravitational force. And then the sum of T1 over T2 of each degree was determined, and so the log T1 and T2 was calculated from the experiment, and the result, the table are complete. Thank you. Now about the test 2 for table 2. So there are different types of angle, which is flat belt, V belt large groove, and V belt with curved or fit groove. And so they are same with test 1, which is as mesh 1 and mesh 2 in gram. So they are repeat 3 times of each type. So the value of T1 and T2 was determined same like formula table 1. So and then we calculate T1 minus T2, and then we calculate all, and was determined, and the table was complete.
During the flat belt experiment, the flat belt is fixed on a 60-degree angle. As the first step in the experiment, the weight that is provided as initial weight is a 500 gram. The cord is then mounted around carefully to avoid any injuries before the weight is hanged to it. When the different amount of weight is added up, the hook is then started to slowly descend, and the different descent between the two experiments. When the 90-degree angle experiment started, it seems to be more descent occurred compared to the 60-degree angle. According to the video, it may seem like no massive error occurring, such as a windy environment, any incidents that leads to injuries and errors for the experiment. Every weight is added gently and carefully so that none of them drop. As the weight is added gradually, the angles of the belt also increasing gradually.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Sarasufah binti Mustafa. My matrix number is CD200230. I will present about calculation. For topic 5, belt friction, we use this formula, which is T1 equal to M1 times G, and T2 equal to M1 minus M2 equal to G. M describe of mass and T describe of belt type. However, for use two equation, we can find for the total of T1 over T2 and log E T1 over T2. This is a calculation that we use that formula. We can find about for 90 degree, 120 degree, 150 degree, and 180 degree. However, we use for find flat belt, V belt large groove, and belt V belt with correct or fit groove. We for flat belt 3 belt we use T1 equal to M times G and T2 equal to M2 times G, and we find T1 and T2.
My name is Nirvash and my matrix number is CD190049. Today I'm here to discuss about the discussion of the topic 5 laboratory lab, which is belt friction. Here I have plotted a graph of T1 versus T2 according to the angle of lab on the same graph paper, whereby the data is based on T1 and T2 from test 1. Discussion on the relation between the changes of driving force with the angle of lab is follows by. Based on the results on test 1, we can anticipate that as the angle of the lab increases, so will the driving force. When the angle of lab increases, the values of M1 to stabilize M2 decreases. Next, I will be discussing on the second discussion of the topic. For the second discussion, I have plotted a graph of log T1 over T2 versus angle of lab, and the data was based on the test 1. For further explanation, I have calculated the values of coefficient of friction of flat belt and review on the results. It was calculated individually for each of the angles. First of all, for the 90 degree, coefficient of friction between belt and pulley is 0.02. Thereafter, coefficient of friction between belt and pulley was calculated for degree of 120 degrees, 150 degrees and also 180 degrees. Those answered would be 0.0018 for 120 degrees and 0.0018 for 150 degrees and also 0.017 for the 180 degrees. Next follows by the third discussion for the topic 5. For the final discussion, I have plotted a graph of T1 minus T2 versus T1 according to the different type of belt on the same graph. This graph was plotted based on the results of test 2. The graph shows that the different type of values have a distinct values of T1 and that are the values of T1 minus T2 for each belt is nearly the same. V belts requires less B width and tension than flat belt. The values of T1 minus T2 of a V belt with a large groove is less than that of a V belt with a correct groove, because the belt tightness of or grip of a V belt with a large groove is not as good as a V belt with a correct groove. That is all from my part, and I have discusses the three discussions on this lab report. Thank you.
In conclusion, the relation between the tight belts and angle of the lap for the flat belt can be determined by the experiment done, and it has been discussed thoroughly in discussion. The driving force at a certain angle can be compared, and lastly, the natural frequency of the beam can be measured and the data obtained. The parallax error might occur since the eyes might not be in the meniscus conditions to the reading. However, the objectives of the experiment is achieved. The tension in the belts for experiments is different in each experiment since it is influenced by the friction force. The tension itself is created when there are one end of it is under tension. As the friction moves across the belt in the experiment, it is clearly that the belt is wrapped around the pulley and the most obvious frictions that exist, and it is called as the belt friction.